Hello and welcome to the EEPROM 9. Today we have a teardown. One of the lights in my bathroom popped, and for you Yanks out there, I'm talking about the room which actually has a bath in it. But yeah, up light, it just popped. It did that typical flashing thing just before it went and never switched on again. So I suspect it's probably going to be the bootstrap circuit that's failed, like a resistor or capacitor or something that I kind of want to debug, because why the hell not? So once again we're stealing Clive's style of video production. You can see the reflection of my lighting for the workbench, and we will get into this. Now this is probably going to be a one-way process, so I've already brought and replaced the this. So this should, this just pops off, and one of the little things I like about these and popping up, they have all the lovely light pipes and that all in there to magnify the nice little LEDs that look like they potentially contain at least 2, maybe 3 chips. I'm not 100% sure there. But this does at least look like it's going to come apart fairly easily. I'm going to fire up the soldering iron because I might need to desolder these. So positive is pink and white, and negative is white. That's a very interesting colour scheme right there. So yeah, nice little 5 LED circuit. Probably why it went pop, because they're not particularly generous on the amount of LEDs in there. But I don't think it's this that failed. And they are all in series, so yeah, that's going to be a decent amount of voltage there. We'll measure it if we can get this thing working. Ah, yes, you are pretty solidly down, aren't you? Yep, you are. Oh, that's a bit... Did you see that? That just bent just so easily. Hang on a moment. This is incredibly fragile. This is very soft metal they've used here. Doesn't even feel like your normal aluminium. On the upside, my soldering iron is heated up. On the downside, this sponge needs wetting, so we're just going to use some squash. And just pour some squash in. Not the first time I've done this. Used squash to melt this, to wet the sponge. To be honest, I need a new sponge, but Maplin's now gone down the pan, so I can't exactly go out and buy another one of these sponges because nowhere sells them. If anyone knows anywhere that sells actual soldering iron sponges in the UK, let me know, because it certainly ain't anywhere I know of. I suspect we're going to want to... Oh shit. As you can see, we're very, very organised here. Hopefully the autofocus on the camera is A-OK with this. Oh, you can tell this is a nice slab of alley, can't you? You know what? I don't fancy fighting with that, so... I'm going to snippety snip snips. If these snips weren't completely buggered. That should make removal a bit easier. Oh, this mofo doesn't want to come out. Oh yeah, we're going to have to get a bit medieval on this thing's ass. So there's several points like this where it's actually glued in with a silicone type glue. So I'm curious if this is a buck or... Yeah, that's what was holding it in. And then, surprise, surprise, this is clamped in down here by these. So here's our little, is it a buck regulator board or switch mode? I'm thinking it's probably going to be a buck regulator of some type. Yeah, that screw basically did nothing. It's just... This thing's pretty well bonded to this alley heatsink, and this is going to be aluminium, but pure aluminium. I'm curious to see what the voltage output of this will be. It's going to be higher than you'd normally think. Oh. I just need to try and keep this in shot so you guys can see. Then we can. Now, the difference between live and neutral doesn't really matter in these because they are GU10s, which can go in either way round. In fact, the difference between live and neutral only really matters in the UK half the time, unless you're dealing with some very specific circuits where they actually use polarised plugs, which does exist in other parts of the world, but not a thing. So yeah, that's just an empty chassis. So yeah, we'll pop that to one side, and this is the point of it. I like the fact there's a plastic cover on this just to ensure it doesn't short out. Alright, we'll see if this capacitor in here is discharged. Yep, no zing over the finger, no zing there. Pop out these. Here's your bridge rectifier. Oh yeah, this is definitely a buck circuit. There's no isolation whatsoever, so you definitely don't want to be sticking your fingers in. This side will be live at mains voltage, and we can even prove that. Will this work on heat shrink? No, I'm going to have to use my other wire stripper. Oh, here's a bit. It's going to be an awkward bastard to pull out by the looks of it. Oh no, we got him. We got him. We got him. We got him. Yeah, that's about right size. There we go. Let's just chuck that to one side. So this will obviously be one of those fuse resistor type things. I personally don't like the fact that you get a lot of these cheap electronics that use resistors as fuses. That to me just seems very bodge. Ah, crap baskets. I might need to use my own. Well, it might be alright. Well, they're saying this multimeter isn't as good as it used to be. Speaking of stripping wires, I absolutely love this wire stripper. It's brilliant. But this wire is not suitable for being stripped by the looks of it. Yeah, this wire is not suitable for being stripped. That's annoying. Yeah, I recommend getting a set of these. You don't have to get the CK ones, they're a bit on the expensive side. We're just going to use a classic old melt the insulation back tactic. Which is surprisingly effective. There to touch that blob. So I want to see if that fuse is good. Well, we might have a point of failure. No, it's 20 something ohms. So yeah, that's using a 20 ohm resistor as a fuse. I hate it when they do that, but that is really quite common. So the last one of these I did. Looks like we've got a capacitive dropper in here for the yeah, that's going to be for the bootstrap circuit. Although it's really just this transistor that's really the main thing, because that looks like a bridge rectifier and it's got the plus and negative on it. So yeah, this is actually a really simple buck regulator. Oh, hello. I think I found our failed component, this little resistor here. It goes from one part of the AC bridge rectifier to this capacitor by the looks of it. Yeah. He looks burnt out. Now if we turn that on to resistance mode, oh yeah, I really need to replace the battery in this meter. Hang on, let me just swap to my Fluke. I could use one of my bench meters, but we'll use the Fluke. There wasn't really the smell of... No, there's not really the smell of burnt electronics in there. Yeah. 6.59 megaohms. That seems awfully high for a buck regulator circuit. So yeah, he got hot and nuked himself. What about the diode? What is your condition? Have you failed? That's good, so you haven't gone short. No, the diode's good. Bridge rectifiers, they barely ever fail. Oh yeah, this is definitely yeah, this is looking to be, yeah, this is an NPN transistor of some type. We've got this yellow, black, red, silver, and red at the end. That will be, I've got my resistor chart up here. Is that black or blue? It's difficult to tell under this light. That's blue, so yellow, blue, red. So that'll be 4, 6, 2 zeros. That'll be 4.6k. So let's see if we've got 4.6k there. The last one of these that I took apart was the resistor that failed. We have we seriously have an OL? Well, if that's the case, that resistor's failed as well, and we've found our problem. Annoyingly, I don't have any of those resistors in stock. But yeah, there's our problem. He went open circuit. This one went pop. Because this one looks like it's supposed to be 4. It would be handy to actually schematic this out. And I'm curious to what voltage this will actually operate at. So I'm thinking, where's my buck regulator? I've got a buck regulator circuit board. There it is. I'm thinking we should jam some voltage into this until we get some voltage out. So I will knock this power supply up to 12 volts. Grab some leads and brought. These are leads which are a bit of a blast from the past I made long time ago. Which means I should not use this power supply, I should use this one. I'll keep it at 15. By the way, this goes up to about 120 volts DC. So it is pretty decent in its capacity. Oh crap, basket, I was just shorting it out. Right, negative, positive. I don't want to get it round the wrong way. That's the correct way. You can't see him on the other side. I can imagine some of you are like, what are you doing using the live as a negative? It's where the power comes from, so therefore it's the negative. It's where the electrons come from. Woot! Here on the EEPROM 9, we don't do all that conventional current bullshit. We only do real current. I've just realised something. I've been monumentally stupid. Why don't I use these in power supply and use these as the crock clips that can hook to these? Yeah, let's do that. Oh, I just heard the dishwasher gurgling away downstairs. Alright, how the fuck does this thing even come apart? Oh, Jesus. Oh. Dumb nuggets. Ah! That's how. And you can't see anything I'm doing. This camera does reds, absolutely. This camera just, reds look terrible on it. Mind you, it is only a cheap webcam. Well, I say it's not cheap actually, it's a decent webcam actually. Because Todd Harrison was awesome enough to donate it to me. And they're actually on the more expensive scale of webcams. I say cheap web, so no, it's not a cheap webcam. I'm wrong there. I'm going to leave this mofo set to 12 volts so I don't electrocute myself doing this. Although I almost lost my fingers to the fan, but that's far less of a hazard. So yeah, I'd recommend picking one of these up. They're actually pretty damn useful. Make sure the pins are facing up. So we'll start by a pretty standard dump 12 volts through it and see what it does. You're positive, so you go in there. Basically, I do the colour codes that make sense to my brain. Plus, brown's closer to negative colouring anyway, so I know it's against the normal convention, but I don't really care about normal convention. It's my lab, my rules. Move all these cables so they're less in the way. This can get up to some pretty dangerous voltages, so you always want to be careful using these. I actually got this from my bench power supply that I built, but then proceeded to forget about it. So, oh, geez, yeah, that's definitely That's definitely bright. As this is a buck regulator, the minimum we can power it at is... Yeah, it keeps overcurrenting, so yeah, these run on a lot less voltage than I thought they did. And ow, my eyes. So yeah, we've actually got a decent current power supply. We can put several, up to 120 volts DC through things on the bench and make them pop, which is good. This is a good thing. I'll probably short the capacitor and make a loud bang. That would make me jump. So we will switch off the power supply so it doesn't blind me. This will give us an indicator of roughly okay. That was just outputting voltage, and now it's not. Ah, weird. I mean, I haven't burnt it out, so I don't know what's going on. There's power there. Oh, weird. Unless the these have just failed. I can try a bit of a more modern power supply over here. So yeah, it's a little buck regulator that boosts it down to 12 volts going over. You're looking at... you're looking at about 9 volts actually. Weird. The buck regulator can run it, but it won't run. How odd. I've got to do this again to confirm it. I can get it to power up on the buck regulator, but not if I do it like this. But not if I just hook it straight up to the power supply. Which I find really... well, dishwasher's just finished. Yeah! It is using hang on, what do I have this set to? Yeah, it's overcurrenting it. So yeah, it's trying to eat too much current. That's actually really interesting. Why is this not there? I am an idiot. Ah, this is out. That's why this isn't set to 12 volt. It's set to 120 volts. So if we set it to say 70, which is quite a common voltage for these, it's actually going to the point it's consuming so much current it's causing this to reset. This can't actually supply enough current to power this LED. That is kind of crazy. And this is actually something where I want to highlight a bit of a safety thing with these power supplies is the output is basically tied to these big 200 volt caps. And if I dig out my multimeter that still has battery, we will actually see they don't discharge straight away. If I put the multimeter in a position you guys can actually see it. Oh, what do you know? It has discharged pretty damn quickly. So it's safe to touch. You're not going to get a zing off that. The other cap is just a measly 100 volts, which, yeah. It makes me wonder, what discharge resistor does it have on it? No, that's not how it's behaving like a cap charging. I don't know. Yeah, so that's why that was doing that. It was trying to dump 100. So yeah, you're looking. Usually they down them to about 70 volts, but this thing can't actually supply the power to run this LED, so it just ends up resetting itself. And that has 5 amps output, so that's actually quite interesting. But yeah, that's a little look at my a little high voltage power supply basically, and that is all I have to say on the subject of LED teardowns. Yeah, little buck regulator circuit. Resistors have failed on it again. Always seems to be the resistors that fail on these. I'm not entirely sure why, but we did get to see it light thanks to my little friend here. I might actually keep these probes permanently attached to this because they're actually pretty good for it. I do want to build this into its own dedicated case at some point, but I currently don't have a case it fits in. So, thanks for watching, and I hope you enjoyed the teardown of a GU10 LED.